What's up, 8th grade? Mr. Agnos here. This video is for homework 14-1. And in this topic, we're going to be looking at scatter plots. And then we're going to use what we learned about linear equations later in this unit to model what we see in scatter plots. So this is an example of a scatter plot, and what we're looking at here is the age and the diameter of trees. Ages and diameters of trees. So we're measuring two things here. We're measuring the age of a tree and then its diameter. And by the end of this unit, what we want to do is we want to determine, is there a relationship between how old a tree is and how big the diameter is? So let me review a couple things real quick. So if you look at this graph here, you can see that on the x-axis, which is always our horizontal axis, we're measuring the age of the trees in years. So we have 10-year-old, 20, 30, 40, and 50-year-old trees. And trees can actually get much, much older. But here we just go up to 50. And then on the y-axis, we're measuring the diameter of the tree. Now, if you forgot what the diameter is, if you have a circle, so imagine this is like a cross-section of the trunk of a tree, right? And then here's the exact center. The diameter would be the distance from one side of the circle through the center to the other, right? So essentially for a tree, we're measuring how wide is the tree, all right? And each of these blue dots up here represents a tree. So I'll just start with this one. So this represents a particular tree that happens to be 50 years old, right? It's 50 years old, and it has a diameter, excuse me, we're measuring in inches here. These are skinny little trees, right? I mean, some trees have diameters that are, measured in feet. And then if we talk about like giant sequoias, those can get to be like 30 feet wide. Well, this one has, here's, if I go over this direction, it's here. It's almost 6 inches in diameter, maybe 5.5, somewhere around there, right? So this tree is 50 years old, and it has a diameter of, I'm just going to say 5.5 inches, right? And then each one of these dots represents a different tree. So I don't know how many we measured here. This maybe 20. I could sit here and count the dots, but maybe we measured 20 different trees. And the reason you do something like this, and we're going to get more to this towards the end of the unit, is we're looking to see, is there a relationship between, is there a correlation between the age of a tree and its diameter? And if you look at this scatter plot, it does seem to have a trend. It does seem to kind of gradually go up in this direction. Yeah, this one's kind of a little what we call an outlier here. But it does seem to gradually go up in this direction, which makes sense, right? As trees get older, right, they're going to get bigger. And maybe this is like one species of tree, right? So it's all the same type of tree, and as this tree ages, of course, it's gonna get bigger and bigger. And then ultimately what we're going to want to do by the end of this unit is, hey, can I construct a linear function that models the growth of this type of tree so that I can then predict how big these trees will get in the future. Excuse me. All right. So let's take a look at some of the types of problems that you're going to be dealing with. We're going to be dealing with a lot of graphs, a lot of x and y coordinates in this topic. All right, so I'm going to do a few problems from the homework. Here's number one. It says, what does the indicated point on the scatter plot represent? So they give me this point here that has the little x through it. That's the one they're talking about when they say the indicated point. All right, well, let's take a look. On the x-axis, we are measuring number of songs. So we're talking about the cost of CDs. That's hilarious. None of you guys know what a CD is, right? Compact disc. So how many songs are on the CD, right? Generally like 12 to 15, but you can even sometimes find CDs that had 20 or 25. So the number of songs is being measured on the x-axis, and then the cost in dollars of that CD. And I guess what you'd be looking for here is, hey, as the number of songs increases, does the price of the CD increase, right? You might, so is there some kind of correlation like we saw with those trees? So they want to know, it says the indicated point represents a CD that has blank songs and costs blank dollars. So the number of songs I go over. It looks like it is at 15. All right, so it has 15. So I go up, 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 up. Yep, it has 15. So I'll put a 15 there. 15 songs. And how much does it cost? Well, to figure that out, I go over. And my arrow's not perfect, but that looks like it costs $17. So again, the whole point of this question was just, hey, can I identify the coordinates of a point? If I were going to write this as a coordinate pair, right, you always put the x coordinate first and the y coordinate second. So this point right here is the point 15, 17. We always put the x coordinate first and the y coordinate second. All right, let's take a look at number 2. I think I'll do 3 of these. Number 2, it says, which point on the scatter plot represents a hamburger that has 28 grams of fat and 490 calories? All right, so if I look at the graph, we're measuring the amount of fat in grams on the x-axis, and we're measuring the number of calories on the y-axis. So I'm looking for a burger that has an x value. That's going to be my x value of 28. So I'm going to go ahead and write that. 28 and a y value of 490. That's going to be my y. So I'm looking for this point on my graph, 28, 49. So I'm going to go over. Notice that this graph, this is just a little side note, this graph starts at 16 and 300. It doesn't start at 0. This is what's called a truncated graph. Basically, you do this when there's no information to show until we get to, in this case, 18, and boy, the lowest number is actually 400. So basically, we don't need all the numbers that are less than 18 on the x and less than 400 on the y, although they did give us some. So they truncate the graph to get rid of all that empty space. So we don't have much empty space. All right, so I want to find 28, 490. So I go on the x-axis. Here is 28, and it's pretty easy. There's only one point there, point D. And again, here is the line representing 500. It's just underneath that. So this is going to be, right, I go over here. This is going to be my point, right? And there would be my 490. So that's point D. Actually, I should use a check mark, huh? X means it's like wrong. This is like winner, winner, chicken dinner. All right, let's do one more. Basically, this first assignment is going to be a lot of review of how to read a graph. Now, we've been working with graphs a bunch this year already. This is really going to reinforce some basic concepts so that when we get to the more difficult material later on, we know how to talk about graphs and use graphs and read a graph. The scatter plot shows the ages and sleep times of 11 people. All right, so they surveyed 11 people. They recorded their age here on the x-axis and how much time in hours they slept. So this is like a real thing. As you age, you sleep less. I remember my grandma used to, wake up at 4 in the morning, and she's just like, well, I just can't sleep. So she would wake up at 4 in the morning, and by 8 a.m. she'd been up for hours and gotten all kinds of stuff done, while the rest of us were just rolling out of bed. And so this is an example of a graph where you can see a clear pattern, right? Now this question isn't asking about that, but you can definitely see that as you get older, this is what's called a negative correlation, right? It goes down as the number of years increases. So later in this unit, we would go ahead and we would say, hey, can we write the equation of a line that models this relationship? But again, there is a pretty clear pattern here. All right, what is the actual question? The scatter plot, use the scatter plot to identify which of these statements is true. All right, they give us 3 statements up here, and we have to figure out which one is true. So let's start with number 1. We're going to look at number 1. There were 2 people over the age of 12 in the group. All right, here is the age of 12 right here, and we have 3 people over the age of 12. So, right, each dot represents a person. So this is definitely not true. Make sure some of them say false. So make sure are you looking for the true statement or the false statement? And this one we are looking for the true statement. All right, 2 people slept for exactly 8 hours. So if I go to the sleep side and I find 8 and I go over, look at that. I have 2 people right there between an 11-year-old and a 12-year-old that slept exactly for 8 hours. So this one is definitely true. So I'm going to go ahead and just check the last one anyway. Everyone in the group slept at least 7 hours. So the way I would check for that, I'll use a different color now, is I would go to 7 hours. Here's 6, here's 8, so here's 7. And everyone here on the left, all of these people, they slept for more than 7 hours. But these people slept for less than 7 hours. And you know what? This is not. Teenagers sleep the most. These dots should be way up here. They should be like up here. That's yellow. The teenage dots should be like, boom, way up here, right? You know, I'm talking about like if this was not a 20 but an 80, right? You get 80-year-olds that are sleeping 5-6 hours because they can't sleep anymore. So which one? Anyway, everyone in the group slept at least 7 hours. That is not true. So statement number 2 is true. And again, be careful. Are you looking for a true statement or a false statement? All right, guys, that should be enough to get you started. Again, this topic is really just about, hey, can I read a graph? Do I remember how to use coordinate pairs and that kind of thing? And then by the end of this topic, we're going to be writing linear equations, just like we've been doing, to model these relationships that we're looking at. All right, ask lots of questions, and I'll see you in class.